Hey everyone, Tony here with Emergitech. In our work with TensorFlow, we noticed performance improvements with newer releases of Windows from the Windows Insider program. With us testing new releases from Windows, I wanted to kick off our video series on artificial intelligence with a walkthrough of installing TensorFlow on WSL2. WSL, also known as Windows Subsystem for Linux, is still an evolving technology with a lot of promise. Now I'm working on TensorFlow 2.4.1 and need to continue to work on this release. If I were to install DirectML, I'd be limited to TensorFlow 1.15. So configuring TensorFlow for WSL when you go off script like I'm doing, it becomes a bit of a research project, as I've had to track down library dependencies to get TensorFlow 2.4.1 to use a GPU inside of WSL, but it does work. In this video, I'll walk you through the steps to successfully install and configure TensorFlow 2.4.1 with GPU support in WSL. Our interest in WSL started with poor performance when training models on Windows 10 with TensorFlow-GPU. When using a NVIDIA GeForce RTX 2080 Super to train models, we maybe got 20% utilization out of the GPU. But when we trained the same model and used the same training files in a WSL-based Linux environment, we reached 100% utilization on the same GPU. Needless to say, we were very interested in continuing our work on Linux. Not only did it provide significantly better GPU performance, we preferred to develop on Linux for scripting. Now all of this occurred in late 2020. Since then we've seen a significant improvement in training models in Windows with GPU utilizations reaching 100%. But we still like using Linux for development. However, one of the underlying problems with WSL is file system performance. In our next video, we'll delve deeper into WSL2 architecture to test performance of WSL as compared to Windows by training a modified ResNet 50 model on both platforms and running some storage performance tests. Okay, let's get started. There are a couple prerequisites you'll need before we install TensorFlow. First, you'll need to join the Windows Insider program from Microsoft and install a pre-release version of Windows. Notice in the lower right-hand corner of my screen is a marquee for Microsoft stating that I've got a pre-release version of Windows installed. When you join the program, join as a developer. Your Windows install will occur more frequently, but you'll also get the benefit of having the latest version of Windows. And I have to admit, the program is pretty good. They keep a decent high-level log of what they are releasing so that you can keep track of what's changing. Second, you'll need to join the NVIDIA developer program to install the latest release of the NVIDIA drivers. Both of these programs are free, but it's the only way you'll be able to get TensorFlow 2.4.1 up in a WSL environment. Now we've tried to configure TensorFlow on WSL in a production version of Windows, and it just doesn't work. And it should be noted that I'm running a Windows Home Edition. You don't need Pro to get WSL to work. However, if you want to work with Hyper-V, you'll need Windows Pro. So moving on to the installation steps. When we last installed TensorFlow on WSL2 in January 2021, through tracing library dependencies until we got it to work, we came up with these steps. I based these steps on several documents and websites produced by Microsoft, NVIDIA, and Google, as well as research on GitHub and Stack Overflow, and by tracing library dependencies. It should be noted that we are not using Docker for any of this, so we won't be covering the implementation of TensorFlow in Docker. First, we will install the CUDA toolkit for Windows and configure WSL2. Next, we will install and update Ubuntu 18.04. We've tried 20.04 a couple of times, but ran into several compatibility problems with the CUDA toolkit. Next, we will install the CUDA toolkit from NVIDIA in Ubuntu. It's important to note that TensorFlow requires CUDA toolkit 11.0, not 11.1 or 11.2. Then we will test the CUDA toolkit to make sure that it sees the GPU. The last time we did this installation, we had to install NVIDIA drivers for Linux to get this to work. However, according to recent documentation from NVIDIA, this isn't needed anymore, as the developer version of the NVIDIA Windows driver, version 470.14, handles this for us. So we'll be skipping this step. When the CUDA toolkit 11.0 for Linux is installed, there are some missing libraries that TensorFlow needs, and libraries that are installed for the CUDA toolkit 11.2. We need to install those missing libraries and revert those 11.2 libraries back to 11.0 for compatibility with TensorFlow. Otherwise, we'll get runtime errors with TensorFlow when we gauge the GPU. Like I said before, this patching was discovered through resolving runtime errors in TensorFlow and tracking down package dependencies in the CUDA toolkit until we found the right versions of the libraries. Now we can install our Python development environment, which in our case is Anaconda. Finally, we installed TensorFlow-GPU version 2.4.1. Okay, let's get started. Let's start with configuring the CUDA toolkit for Windows. On the NVIDIA developer site, select Downloads from the top menu and find the CUDA toolkit. This will not only install the NVIDIA drivers, but also prep Windows 10 for running TensorFlow on it as well. Then select Download Now. Since we need CUDA 11.0, we'll need to go to the archive. Find the CUDA toolkit 11.0 dated May 2020. Select your operating system and architecture. I've selected the local install, but the choice is up to you about how you want to approach the installation. If you have decent network bandwidth, then use the network install. Once it's downloaded, execute it. After you've read through the license agreement, select Custom Installation to get an idea about what will be installed. This may be important later during the debugging of your environment, so take note of what the installer is doing here. I already have version 470 of the Windows NVIDIA driver installed, so it won't do anything here. I will leave a link in the description about where you can find the latest NVIDIA drivers. Then continue with the installation. This will also delete any previous CUDA installations you have. Finally, you can see what the installer completed and did not complete in the installation. Now we need to configure WSL2. The directions are well laid out on this site from Microsoft, so we'll just walk through them quickly. You'll need a command prompt with administrative privileges to execute these commands. Do step 2 first and make sure you have the right version of Windows installed. If you joined the Windows Insider program and installed the latest version of Windows from that program, then this requirement is met. Next, perform step 1 and enable the subsystem for Linux. Now on to step 3 and enable the virtual machine feature. One thing I should note here is that you need to check your BIOS to make sure you have the virtual machine configuration set up correctly for your processor. Otherwise, this won't work. Check your motherboard documentation for how this is done and where it's located in your BIOS. Next, reboot your system. Now you need to update the Linux kernel. Use the link in step 4 to download the updater and run it. Now set your default version of WSL to version 2. Now get your distribution. As I said before, we've been able to get this to work with Ubuntu 18.04. 20.04 has several issues with CUDA toolkit and TensorFlow. Let's go to the Microsoft Store and get Ubuntu 18.04. Then we will launch and set up our user ID and password that we'll use for this distribution. After getting the user ID and password configured, I like to modify the prompts to let me know what distribution I'm in. So a quick edit to the .bashrc file using nano will do it. Add 18.04 to the prompt. Then Ctrl-O to write the file and Ctrl-X to exit nano. Okay, let's update Ubuntu with the standard apt update and upgrade commands. Now we've opened Terminal and ready to update Ubuntu. I like using Terminal because I can copy and paste commands right into it. Now we will get the CUDA toolkit for Linux. Because we need 11.0, we won't be following the configuration recommendations from NVIDIA. Instead, we will follow the steps I have laid out in the description. First, get the key. Now we will copy it for apt and prepare apt. Now install the CUDA toolkit. Again, we'll specify 11.0. Now we need to test the CUDA toolkit with a sample that was installed with the toolkit. Let's use black shoals. So navigate to its location and then make black shoals. Then run it by copying the path and executing Black-Scholes. And there we have it. The CUDA toolkit is talking to the GPU. Now it's time to patch the CUDA toolkit libraries. I've got all the libraries listed in the description below, so just follow the commands listed. At this point, we have all the libraries to support TensorFlow installed and patched. Now we are ready to install the development environment. In our case, we'll use Anaconda. So let's first install pip and check to make sure that it's installed correctly. Now install Anaconda. Let's grab the package and execute with bash. Do not run this as root or you'll never get Anaconda to work correctly. Enter through the license agreement. Set the home directory, which I'll use the defaults, and proceed with the install. Confirm the installation. And now open up a new terminal window so we can use our new development environment. Now we need to update Conda, Anaconda, Python, and everything else. With the development environment ready, we can install TensorFlow. We are using pip here as we need 2.4.1 and Conda will only install 2.2. We are ready to test to see if TensorFlow can see the GPU. But before we get started, we need to tweak a Jupyter Notebook configuration. Otherwise, we'll get a harmless yet annoying error message on the console. It's a quirk with WSL, but this change will bring up your default browser automatically. First, we'll get Jupyter Notebook to generate a configuration file. Now we edit the configuration file with Nano. We are looking for the use redirect file flag. The good news is that these configurations are alphabetical. Now we need to change the use redirect file flag to false. Now let's start Jupyter Lab. I've already got a script written that will test whether TensorFlow is talking to the GPU. We see the correct version of TensorFlow is installed. And bingo, TensorFlow sees the GPU. We also see our GPU in the console. So in summary, the installation of TensorFlow-GPU onto WSL was simplified by not having to install an NVIDIA driver and matching that to the Windows driver. While you can script the install process, we wanted to go through them one step at a time. I've documented each of the commands issued in the description below. If you've had a different experience with configuring TensorFlow-GPU on WSL, please leave a comment. I'd love to hear how your deployment went. And let us know your thoughts on using WSL for TensorFlow development. As Microsoft, NVIDIA, and Google continue to mature their respective platforms, we will be posting updates to this video showing their relative progress. Our next video will delve a bit deeper into the WSL2 architecture with a benchmark of training a ResNet 50 model on both WSL and in Windows. If you like this content, please give this video a thumbs up to support the channel. And please consider subscribing for future AI content. I thank you all for the kind support, and I'll catch you all next time.